Let's suppose that we're asked to determine the value of the integral from negative infinity to infinity cosine 2x divided by x squared minus ix plus 6. The first thing that I want to do is factor the denominator. I'll get x minus 3i times x plus 2i. So I've got a simple pole at 3i and another at negative 2i. All right? Now, when I am doing this integral, as we've seen, I can't close this real part of the contour in the upper half or lower half with cosine. The cosine is unbounded both in the upper and lower half planes. So what I'm going to have to do is split this cosine up. So I'm going to write it as 1/2 integral minus infinity to infinity e to the I 2x dx divided by x minus 3i times x plus 2i plus 1/2 e to the minus I 2x just like that. All right? And now, in the first piece, it's okay for me to close in the upper half plane. All right? The exponential is going to be exponentially suppressed in the upper half plane. And that means that the semicircle at infinity will vanish as r tends to infinity. For the second integral, I'm able to close in the lower half plane. All right? The integrand will be exponentially suppressed. So the semicircle at infinity in the lower half plane will vanish for this one. Okay? That means that each of these is equal in the limit to the loop integral. So let's see what those values are. I'll have 1/2 loop integral. 2 pi I, I'm picking up the pole at 3i. I multiply by z minus 3i, and I take the limit as z approaches 3i. Here, when I close in the lower half plane, I'll get a clockwise oriented loop integral. And that's going to cost me a minus sign. Now I'm picking up the simple pole, negative 2i. Just like that. Okay? So cancel. The I cancels. I'll get pi over 5, and then e to the minus 6. Minus and minus cancel. I cancels, 2 cancels. Plus pi over 5, e to the minus 4. And so if I wanted to, I could write this as pi divided by 5e to the 6th times e squared plus 1. All right? Now, notice that if both of the poles had been, for example, in the lower half plane, so suppose that instead it had been x plus 3i, x plus 2i, this integral would have been 0. Okay? So this one wouldn't. This one you'd pick up both of the poles. All right? If I had started off with something like this, then the integral is simply 0. I can close in the upper half plane, and I won't capture any of the poles. So that would just be 0. But the e to the minus x example would not. Okay? It's not difficult. You just think about what you're allowed to do and the implications that that has.